Okay, so now we're going to deal with some logarithms and exponentials. So we have x equals e of t and y equals e to the negative 2t, and we can plug in any t value we want. So you can possibly see this is a nice quick substitution there. As x is equal to e to the t, we can just go, well, y is equal to e to the t with a negative 2, since these are just multiplied. And then we can take our x and just plug it in. So y equals x to the negative 2, which would mean y equals 1 over x squared. But we need to look and see how things work here. So if you look at e to the t is always greater than 0. So e to the t will always be greater than 0 because it's our exponential, right? So as long as our t is positive, it grows exponentially. And if our t was negative, it would just have an exponential decay, both of which are greater than 0. So that means if you look at our e of t here, if it's always bigger than 0, so is x. So our x here must be greater than 0. And we know it can't be 0 because look at our denominator. X can't be 0 here. But that means we're not getting any negative values over here. So when we think of our rational expression as we'd have that shape like this, we're only going to get the second side over here. So that is our track for our y equals x squared. It looks like this. So now all we need is direction. And there's our direction. So if we plug those into our calculator, we'll see what shape it is. So second e to the t, second e to the negative 2t. Now, we know that our t can be anything we want. So we're going to go to our window, and we're going to make it like negative 10 and 10. And then we're going to graph it. And you can see there's our shape. Nothing over here, just like we know. And so if you saw this in your graph and go, why is there nothing over here? Then you go back and look, oh, e to the t must be bigger than 0, so our x. Remember, these are just the x and y coordinates that are being given to us by the t. The t just gives us motion. So now if we go to our table set, and we're going to start our table at, since t can be anything, how about negative 10? And we'll do a change of 1. And then second table. And you can see these are our values. And so there's a nice one, 1, 1. So let's scroll down to there and see what happens. So we have an x value of 1, 1. And that's a t of 0. So t of 0, we get 1, 1. That's actually very nice. Look at that. See, if that was 0 and 0, it would be 1, 1. So let's make this a little nicer here. Let's bring it down. There we go, like that. 1, 1. And then we move on from there. So this would be 1. So if I plug in 1, I'd get e. And if I plug in 1 here, I'd get e squared as a denominator. So 1 over e squared. So that's my 2.7. So you can see we're going this direction here now. I'm right here. So we already have the direction. We're going that way, which means that is the direction on our shape. And if you pull up the calculator, you'll see that as well. You can see that as our x increases this way, our y is getting smaller. So this way. But you could even just make it really easy, as that's my t. And which way is my x going? It's getting bigger. See it right there? Boom, 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 boom. We're going this way right now. So we're moving this direction with t. So there's my equation. There's this. And then we also know with e to the negative 2, that's just a decay, right, as the t goes bigger. So again, y is the same thing. Y is greater than 0. All right, let's try another one. This one now we have a natural log. So what we could do with the natural log is rewrite it as an exponential. So y equals ln of t. That's a base e, right? So we get e to the y equals t. Now we just solve for t and we can plug it in. So x equals t squared. So x would be e to the y squared. That's a y. So this would become x equals e to the 2y. And so there is our exponential. So it's an exponential growth problem, but for y, because we have x equals e to the 2y. So we're doing this like that. So now if I plug in my t, you can see that's another good one right there, 0, right? So if I use t equals 0 and I plug it in, you can see my x is 0 and my y, ln of 0, is not good. You can't have a natural log. So you go back and go, oh wait, that's x equals 1. So that's where you want to start. T equals 1. So if I plug in 1, I get x equals 1. And then the natural log of y is 0. So there's my point. Now I just need to see which way am I going. Am I going to go this direction or this direction? So why don't we move on to t equals 2? Because we have to move in that motion. T equals 1, t equals 2. So now my x, if I plug in 2, would be 4. So we already know we're over here. 1, 2, 3, 4. We're here for my next point. So we are moving in this direction. But just to finish it, that would be ln of 4. And there we go. So if you look at this, the x value itself, it has to be bigger than 0. So x here is greater than 0. And my y is all real numbers. So I'm just going to put that, all real numbers. And we know that because we don't have anything over here. We can't plug negatives into a natural log. So if you think about the x, if I were to plug in 0, it's not going to work. If I were to plug a negative in for t, they're not going to work. The first number I get that's nice is 1. So anything bigger than 0. This is an exponential, see, just like this. So we know just looking at that, our x is greater than 0. And there you go.